Welcome back to Unit 1 of High School Statistics. In this lesson, we're going to learn three important ways to describe a set of data: the mean, the median, and the interquartile range, or the IQR. When we collect data, we often want to find answers like what is a typical value, what is the center of the data, and then how spread out are those values. The mean and the median, they help us to find the center. They're different measures of center, but they can both help us to find the measure of center. While the IQR helps us measure how much the middle portion of that data varies. So we're going to start by looking at calculating the mean and the median from data displays. And then we're going to look at looking at some patterns for being able to estimate our answers for these after we do a few practice problems with exact answers. So this first example says Jade recorded how many characters she used in each of her 9 most recent text messages. Here's a histogram showing her data. It says which interval contains the median number of characters. So we have a histogram. It looks like we have intervals of 10, even though it doesn't list it there. I'm just going to write a 10 there just to kind of make a quick note that those are going up by tens. So to find the median, that's the middle value of our data set. There's 9 values total. Um, so we have to figure out what's the middle of 9, first of all. So we're going to find that middle number. Like, what is the middle? What is the middle value going to be? So if we just list out 1 through 9 in a list in sequential order, um, we just have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're looking for the median of that. To find the median's the middle number. And I was able to eyeball that and find the middle number. But another method that you can use to find the middle number is you cross off the leftmost number and then the rightmost number. And then you keep going down the list. Left, right, left, right, left, right. And you keep going until you get one number in the middle. Sometimes we have 2 numbers in the middle. If that's the case, you add those together and divide by 2, and that gives you your median. In this case, we just have 1 number though. So our median is equal to 5. Okay. So all this data is listed in sequential order on the histogram. So we are looking for which group is going to correspond for a total of 5 messages going in sequential order. So let's take a look at what each of these groups are. I think that'll make more sense here. So if we look at group 1, I'm going to say group 1 is between 0 and 10 people, or 0 and 10 characters, excuse me. And we want to know how many messages correspond to that group. Well, it looks like we have 3 messages for that group. For group 2, that's between 10 and 20. And for group 2, it looks like we have 1 message. For group 3, between 20 and 30. And we also have 1 message. Okay. So now it's saying which interval contains the median number of characters? Well, the median number of characters is going to be it's going to be 5. So, excuse me, the median is going to be 5 in terms of the number of messages. So we want to find out if we were writing all this out and adding together these groups, we want to get to 5. In this case, group 1, group 2, and group 3, if we total those together, that equals 5 messages. And we got that 5 by finding the median of 9, which is 5. So let's kind of recap one more time. She has 9 text messages, and we want to know the middle the middle value of those 9. The middle value would be uh, 5 text messages. So if we add all these bars together, we would get 9 altogether. So if we added all those together, we get 9 messages total. 3 plus 1 plus 1 plus 2 plus 1 plus 1 gives us 9 messages. So in the very middle is going to be at 5 messages. So starting at 0, from 0 to 10, we have 3 messages up here. 10 to 20, we have 1 message. 20 to 30, we have 1 message. That would give us the 5 messages that we're at. So from group 3, 20 to 30 is 5 messages. And so that's the interval that contains the median is 20 to 30. So when we get to 5 messages, we stop at that interval, and that's our answer for the median. Let's look at another median question that is with a dot plot instead. Here it says Miss Gomez was looking at how many students are in each of her classes. Find the median number of students. So first, let's figure out the total. The last problem told us there was 9 altogether. Let's see how many data points we have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. So we also have 9 data points. That would be our first step, is count the data points if they don't tell us. And here we have 9 of them. Next, we're going to find the median of that 9. Find the median of 9. And so I'm just going to write a list 1 through 9 with integer values. And then we find the median. Now, this is a little easy because we just had this on our last problem. Median is 5. Okay, so now that means we want to find the 5th data point, starting at the first data point being the lowest value. So 1, 2, 3, 4, 5. The 5th data point lands here. Or we could say here, either one's fine. That'd be the 5th data point is at 25 students. And so that means that the median number of students is 25 students. So maybe it should write that out. Find the 5th data point and then just count on, or we'll say check the dot plot in this case. Or the last one, we were checking the histogram. Okay. Let's look at one more of these. This one is a little bit tougher, but it's asking us, I believe, the same. No, it's asking us for the mean this time. So it's asking us for a different question. We were looking for the median, which was the middle number. Now we're going to look for the mean, which is the average. It says, sometimes Zach's teammates arrive late to basketball practice. The following dot plot shows how many times each teammate was late to practice last week. Find the mean number of times Zach's teammates were late. So here we don't really want to find the middle number. We want to find the average. So the mean is the average. I'm just going to write that here. Another way that we write the mean in statistics is X bar, or sometimes we write it as mu, which looks like a letter U with an extra piece on the left of it. So that's what the mean is, and that's how we write that as a variable. Okay, so to find the mean, what we do is we add the individual data points. So we find the sum of them, and then we divide by the number of data points that there are. And you've probably done this in previous grades. I'm going to show you a slightly more advanced formula for the mean. It means the same thing though. So here we have X bar is equal to the sum of, that's sigma, and we're going to see that in our statistics course throughout the year. The sum of n, and then where I is equal to 1 times xi, or x sub I, and then divided by n. All this means here is the sum of uh, our values uh, times each individual data value. And then n is the total number of data values that we have. So a much more simplified version is the formula that you probably remember from earlier in school. To calculate the mean, let's do that. The average is we're going to add together all the values. So we have 1, 2, and we have 1, 2, 3, 4s. And then we're going to divide by the number of data points there are. There's 4 blue dots there. That's what our n is equal to. So again, this sigma just means the sum of n, which is all of the n's, or excuse me, all of the data points that there are. And then I equals 1 means we're going to start at the first data point. So that's a little more accurate way of reading what that is. And then x sub I just call it xi sometimes. That's just each individual data value. Okay, so we're just adding together all of them and dividing by the number of pieces that there are. So now this is equal to 14 over 4. As a decimal, that's 3.5. So on average, his teammates were late 3.5 times. Now, what's interesting about the average is it's not even on our dot plot as one of the dots. So just kind of keep that in mind, that the median is the middle value and the mean is the average, which is not always going to be represented on our histogram or our dot plot. Okay, now we're going to look at estimating the mean from data displays. It's getting a little bit tougher because I think these are tough because if you estimate without using a formula, um, you can get a rough idea. But if you're answering these on Khan Academy, it might be better to just actually calculate what it is. And the reason I say that is when we're estimating, sometimes we could be very close to something, but then our estimation is slightly different than another estimation. So we'll look at actually calculating what these are. But here's a quick way that you can estimate the median and the mean. To estimate the median, you look for a point that splits the data into 2 equal halves. So imagine moving from left to right and accumulating data. The median is located where about 50% of the data is below it and about 50% is above it. So that's the median. Just going to say 50% of the data is above the middle and 50% of the data is below the middle. Okay. So you can also let's solve for the exact value for this. So here we have 31 athletes on this agility test, and we're given their scores for their agility test, and it says how many athletes got these different scores between 0 and looks like 0 and 1, 1 and 2, 2 and 3, and so on. So we want to approximate the location of the median. So in this case, the median is going to be 16. So for 31 data points, If you wrote a list 1, 2, 3, all the way out to 31, and you did the method where you cross off the left and the right, left and the right, and you went all the way to the middle, you would get 16 is the median. Okay. So now we want to find the 16th value. So for letter C, it looks like we're at 13. If we look at C, that's 13. And for B, that's at 5. And A is at 2. So what the median tells us is we have 15 data points on the left and 15 data points on the right. So we have to figure out which interval is the median at. So let's look at where 15 data points on the right. Well, the C was 13, the B is 5. That puts us at about 18. Let's look at the left side. We've got 2, 3, 5, 6, 7, 8, 9, plus 2 more gives us 11, plus 2 more gives us 13, plus 5 more gives us 18. So that means the median's got to be around where B is. So that's how we can find the median more accurately using the counting method. Now, if you want to actually estimate this, you can. You could say, okay, we have where's about 50% of the data, and you could start counting, and you could say, if you didn't know if it was 31 exactly, you maybe want to find that out first. But you'd check the left and the right and try to estimate where the middle is. Okay. The mean takes a little more time to calculate. Um, I'm going to show you the way to officially calculate it, which is technically called the weighted mean. That's something we're going to learn later on in the year. So um, if this is a little bit confusing right now, that's okay. But I think you'll understand this, and then when we get to this later in the year, it'll be really good review. So the weighted mean also is called the weighted average. And to find the weighted mean, we take an individual data point times its frequency. So I'm just going to write this out. Individual data point times the frequency. And we're going to divide that by the number of data points that there are, or n. Another way that we can write this is the sum of f sub I, x sub I over the sum of x, or sum of f sub I. That's just another way we can write this, another notation. But let's take a look now at what these individual data points are. So a person who got a score of 0, that's our first group there. 0 times, there are 2 people that got the 0. So 0 times 2 plus, because we're taking the sum of, that's what sigma is telling us. For somebody who got a 1, there was 1 person who got a 1 if we look at the next part of our histogram. And we're going to go down the line for all of our histogram here. We try to zoom in a little bit. So for somebody who got a 2, there were 2 people that got a 2. 2 times 2. Plus there was 1 person who got a 3. 3 times 1. Plus somebody who got a score of 4. There's 1 person who got a score of 4. There is 1 person who got a score of 5. 5 times 1. There is 1 person who got a score of 6. 6 times 1. We're going to keep going. Somebody who got a 7. There's 2 people who got a 7. There are, for somebody who got an 8, there's 2 people who got an 8. You got just a couple more to go here. And if it's getting a little small to read, I apologize. I'll try to zoom back in a minute here. And then score of 9. Looks like there were 5 people that got a score of 9. And then finally, there were 13 people who got a score of 10. Okay. And again, this is not required for this assignment. This is the weighted mean. If you want to try to estimate what the mean is just by looking at this, you can. But I would encourage you to try to solve this with the weighted mean. Now we're going to divide by the total number of data points. There's 31 data points altogether. So again, we took the group from the histogram and we multiplied by the frequency. And then we found the sum of all the groups times the frequency and divided by the total. This is called the weighted mean. So it's very similar to the mean where we add together all the parts and divide by the total number of parts. But here we have multiple frequencies of a number. So we're multiplying to find the frequency times the individual data points. Okay, so now we're going to simplify the numerator. 0 plus 1 plus 4 plus 3 plus 4 plus 5 plus 6 plus 14 plus 16 plus 45 plus 130. And we're also going to divide that by 31. That's the same, just simplified from the top. Okay, and this ends up becoming 228 divided by 31, or approximately 7.35. And that's our weighted mean. Okay, now we have to figure out, what is this even really telling us? Well, the 7.5, we're looking to find the frequency for a score of 7.5. So we're going to add together all of these again. See here. So we're going to find a frequency of 7.5. The closest for this one is going to be A. So when we look here, you got 2, 3, you got 8 right here. 7.5 is between 7 and 8, which is actually here, but it says to estimate. So for this one is going to be A. It's got to be the closest one. It says find the approximate location of the mean. And so that's how we find the weighted mean. And then again, this is just a reiteration that we're finding approximate values. So this is just using the methods for estimating can save us some time, but we're going to revisit the weighted mean later on as well. Let's take a look at one that's a little bit more simple. This next one says, the meteorologist recorded daily high temperatures in their city for 62 consecutive days. Here are the temperatures. And it wants us to find the mean and the median. This one's a really nice example because our data is symmetric. And because our data is symmetric, that means that the mean and the median are the same thing. So the mean equals the median with symmetric data. And we can see this very clearly that the median is B, and the mean is also B. If we added all these together, if we did the same method as before with our individual data points times the frequency divided by 62 is the total number altogether, we would get our weighted mean, which would fall within the median. So this one's B and B. That one's a little bit easier. Let's look at one more of these with a dot plot. It says Karina watched a basketball game and recorded how many points each of the 18 players scored. Here are the results. And we want to find the approximate location of the median and the approximate location of the mean. Another another way we can estimate the mean, and I forgot to mention this earlier, is I think this is probably going to be a really quick method if you're wanting to steer away from the weighted mean. Think of the graph as a physical object that's made out of cardboard. The mean is the place where you would have to balance it at a balance point. So areas with more data pulls the mean toward them, but long tails also pull the mean in their direction. So for going back to this problem here, we think about A, if we were balancing this on a balance beam or something, the pivot point where we balance it at would be at A because all of C and B is much heavier and it's pulling it down to the right. And this is lighter, but there's more of them pulling it down to the left. So the balance point would be at about A. Now, if you weren't spending a lot of time on this, you might say it's B also. So just keep in mind that we might still need to calculate the weighted mean. Okay, back to the weighted mean for the dot plot. Karina watched this basketball game. She recorded how many points each of the 18 players scored, and then we have the results here. Okay, so we want to find the approximate location of the mean and the median. Let's start with the median. So we're looking for the median of 18 players. So for 18 players, we're going to write a list 1 through 18. That might take us a little bit, but this is just to show you how we calculate the median uh, when we have, in this case, I believe we're going to have two numbers in the middle. So just keep writing our list here. 16, 17, 18. Okay, now we're going to cross out on each side. Left, right, left, right, left, right, left, right. This is how I do it. It helps me to really make sure I find the middle number. You do one on each side. Just keep the pattern going. So now we have two numbers as our median. So that's 9 plus 10 divided by 2, which is 19 over 2, which is 9.5 is our median. Okay. So now we want to find the 9.5 value on this list, and that's going to tell us our median. So we have 1, 2, 3, 4, 5, 6, 7, 8. There's our ninth value. There's our 10th value. The 9.5 value is between 9 and 10. That's got to be A. Okay. This one, we can take a little bit of a shortcut to find the mean. Instead of doing the weighted mean, there are two outliers to the right. So there's just these two are much higher values. That's going to pull the mean upwards higher than the median. Because our two outliers make us so we've got to add together much larger values on our numerator while we're calculating the mean. It does something called pulling the mean upward. But it's only going to slightly pull the mean upward because there's only two outliers. There's just a couple of large values that pull this median or pull the mean up past the median. So the approximate location of the mean is B. Again, these are just estimations. So as you practice more of these, you're going to begin to recognize more and more patterns. Okay, next we're going to talk about interquartile range. So the interquartile range measures how spread out the middle half of data is. To find it, we subtract the first quartile from the third quartile. First quartile is the first 25% of the data, and the third quartile is the next 75% of the data. We subtract 75% minus 25% to give us the middle half or 50% of our data. So it says that we have these data points for the number of classes that somebody teaches in high school. They want to sort this data and then find the IQR. They want to sort it from least to greatest or in sequential order. So this is a drag and drop activity. I'm just going to write it out though. So I'm just going to say organize data in sequential order. Okay, so we've got one. We're going to cross these out as we go. There's no twos. Looks like we've got 3, 4, 4, 5, 5. And I'm not really going in exact order because this is just how I'm seeing these show up in my brain. 3 fives, 6, 7, and 9. Okay, so we're gonna count how many points there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just double checking our list. Okay, now we're gonna find the median. Okay, to find the median, we're gonna start left, right, crossing out left, right, left, right, left, right, left, right. There's our median, 5. Okay, now we want to find the median of the lower half. So we're going to look for what our quartiles are. So I'm going to write find the median of the lower half. That's quartile 1. And we're going to do the same thing for the median of the upper half. And that's quartile 3. So I'm going to rewrite this list, even though we just crossed all those out. But I'm just going to rewrite it really quick here. We had 3 fives, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here's our median on that first 5. So now we want to find the median of this first half here. So we have 1, 1, 3, 4, 4. So quartile 1 is the middle number, and it's easy to see. We won't cross them off like we did the last time. It's 3. If you want to, you can, but I'm just going to not cross them off so we can see a little better. Median of the upper half is 6. So that's quartile 1, and that's quartile 3. Okay, so again, these quartiles, they divide the data into roughly 4 equal sections. So here's our median. So now we can say this is section 1, this is section 2 from quartile 1 to the median, from the median to quartile 3, section 3, and from quartile 3 onward is section 4. So we've just divided our data into fourths. Finally, we're going to calculate the IQR. So to calculate the IQR, or the interquartile range, that's equal to quartile 3 minus quartile 1. That's going to be equal to 6 minus 3. And the interquartile range is equal to 3. Now, this means a spread of 3, or the middle half of the data is 3, which is how far apart these data values are. Let me write this list one more time. So 1, 1, 3, 4, 4. We had 3 fives, 6, 7, and 9. So the interquartile range is 3. That means that from here to here, all of this stuff, the spread is 3 apart from Q1 to Q3. So this is 50% of our data from Q1 to Q3. That's how we would write that out in a list form. Let's look at one more of these. It's going to be the same kind of a problem, except I think we've got to do a little bit more math because we get 2 numbers for our quartiles. So let's look at the next problem. So this next one says The following data points represent the number of attendees at each of the dance events hosted by this event center. Let's sort the data, then find the interquartile range. So we're going to organize in sequential order or list in sequence. So I'll start with the lowest number, 32, 34, 35, 35, 39, 40, 44, and 47. Okay, now we're going to find the median. And again, we would cross off left, right, left, right. We've done that a few times already. So I'm just going to circle the median. And this time we get a median of 2 numbers. That's our median. So we've got to actually calculate what that is. 35 plus 39 divided by 2 gives us 74 over 2, which is 37. That's our median. Okay, so now when we rewrite our list, we want to find now quartile 1 and quartile 3. Find Q1 and Q3. I'm just going to quickly rewrite the list and show you how we write the median for this in terms of how we're separating this so we can accurately find the quartiles. So the median is here. That's where we're going to write our median. It's not both of the numbers, it's exactly in the middle. So now we're going to look at what our middle number is from these 4 numbers to find quartile 1. And that's these 2 numbers, which we have 2 numbers now. So we're going to divide by 2. So we're going to do the same strategy that we did for the median. This is essentially finding the average of these numbers or the mean of these numbers. So for Q1, it's just 34 plus 35 divided by 2. And that's 69 divided by 2, which is equal to 34.5. That's Q1. Okay, for Q2, we also have 2 numbers in the middle. Or excuse me, Q3, it's 40 plus 44 divided by 2, and it's 84 over 2. And that's equal to 42. Okay, so now we have quartile 1 and quartile 3. The last step, we're going to calculate the IQR. And to calculate the IQR, that's just quartile 3 minus quartile 1. Which is equal to 42 minus 34.5. And we get a final answer for the IQR of 7.5. Or we also say this is a spread of 7.5 between quartile 3 and quartile 1. And that's going to be our answer we put in the box for this is 7.5 attendees is the quartile range or the interquartile range. Next lesson, we're going to examine how to more accurately represent quartiles graphically using box plots. But now we have at least a basic understanding of what the median and the mean is and what the interquartile range represents in terms of percentages of our total data.